This is Chris, and we are taking a look at our very last multiple choice question here in section 3 of SAT Practice Test 4. And this question is a difficult question. I'll just flat out say it. Sometimes there are cool tips and tricks where you can make something a lot easier and something that you can answer a lot faster. And then sometimes you get a question like this. I call it a true 15. This is number 15, which in theory should be the hardest, or certainly one of the hardest questions in the multiple choice section. And guess what? This one is definitely a true 15. It really is as hard as a typical question 15, is cut out to be. So here they give us this expression and they want to know the solutions for x. And if we look at our answer choices, hopefully we recognize at least some familiarity with the way that these answer choices are written out, because these all look kind of similar to quadratic formula, and that helps point us in the right direction of how we should answer this. We're going to answer this using quadratic formula, and this might be a video that you want to pause at different times to make sure we understand all the steps. So to prevent the video from lasting an hour, I'm going to go through this relatively quickly, but there's a lot of complex algebraic simplification that goes on in this question. So if you do run into any trouble, again, feel free to pause, rewind, rewatch, whatever you need. But here we go. So in order to apply quadratic formula, we want to get something in the appropriate quadratic form, which is going to be our ax squared plus bx plus c. And to do that, we bring this constant 2p over to the other side. So we're going to have x squared minus k over 2 x minus 2p equals 0. And once it's equal to 0, so now it matches this quadratic form, which means that we can identify our values for a, b, and c. So in this question, we have a coefficient of 1 on the x squared term, that's a. B is a negative k over 2, that's our coefficient on our x term. And then c is the constant at the end, which is negative 2p. And we have to plug that into quadratic formula. In quadratic formula, this we should definitely memorize. I'll maybe put this in red just to color code it a little bit, but quadratic formula is negative b plus or minus square root of b squared minus 4ac over 2a. So these are your solutions for x. That's what x would equal when solving something that's complicated like this and something that's not easily factorable. Sometimes we have to use quadratic formula to solve. So in this case, we can, let's move this over a little bit, but in this case we can plug in these values, and this is where the math is going to start to look complicated, but see if you can follow along. So here, when we plug in a negative k over 2 for b, we have a negative of a negative k over 2, so that's going to give us positive k over 2 plus or minus square root of negative k over 2 squared. So for right now, just write everything out as is as much as possible. 4 times a times c all over 2 times a. And then here, so again, we're going to keep simplifying. This is k over 2 plus or minus square root. So this will be k squared over 4 plus 8p. Whole thing's over 2. And to simplify inside of that root, so for these couple terms here, we want to try to find common denominator. And so when we do that, we're going to get a common denominator of 4. And this would be k squared over 4. And if you multiply the 8p and the 1 times 4 to get your common denominator, this will be plus 32p over 4. The whole thing's over 2. And so if we rewrite that as one fraction, this is k over 2 plus or minus square root k squared plus 32p all over 4. And then the whole thing divided by 2. And remember, when you're taking the square root, you can take the square root of the numerator and denominator separately. So if we take the square root of that denominator, we get here if we take that square root, we get k over 2 plus or minus, and this will remain root k squared plus 32p. But then no longer inside the root, we'll have now a 2, the square root of that 4. And the whole thing is being divided by 2, which means we divide each term by 2. And when we do that, divided by 2 just means you're doubling your denominator. So this will end up as k over 4 plus or minus square root of k squared plus 32p over 4. And if we're checking our answer choices a little bit as we go to try to see which one is going to match and when we can stop simplifying, we see here that this matches what we see in answer choice B. So definitely a tough question, definitely a lot of algebraic manipulation and simplification, definitely a lot of outside knowledge in terms of knowing quadratic formula and being able to apply it, on a question this complex. So, if this is one that you run into trouble with, strategy-wise, the most important thing that you can appreciate from a strategy perspective here is that if this is question 15, and right at the top you can tell it's going to be tough, and you can tell it's going to take a long time, make sure that you mark that one to come back to. Take a look at your grid-ins, because once you get to question 16, and you start those grid-ins, remember that difficulty resets. So you don't want to run out of time working on 15, which is very difficult, when you might have a few easy ones in question 16, 17, or 18, coming up on that next page. So just make sure that we're smart about where we apply our time when we do get to questions this difficult. And if you are able to apply the knowledge needed here and find those values for A, B, and C and use